3D models are detailed objects that are made in an external modeling program like Blender, 3ds Max, Maya. There's a lot of others. The easiest way to get 3D models into your game is to just download them from our downloads system. We have a lot of them available for you. Let's choose this one. We just press the install button. And there it is. We can open this up in the model editor and look at it. And if we want to place this in our scene, we just drag like this. And there it is. You can also download 3D models from external websites. I have a zip file here from a website that contains a GLTF file. And I'm just going to extract all the files inside this zip file into my models folder. And there's the model. If I double click that, it opens it up in the model editor. And usually, so GLTF files, they support PNG and JPEG textures file format. And this is not optimal for real-time rendering. What we usually want to do is go up to Tools and then select Convert Textures to DDS. DDS files are compressed in memory, and so they load faster, and they also use about 25% as much memory as like a PNG file does. Okay, it says we converted 3 textures. And then because GLTF does not support DDS files as textures, we want to save as, and we're going to save this as the Leadwerks model file format, which does support a lot of other features that GLTF and other file formats do not. And the GLTF loaded pretty fast, but this definitely loads faster. And you can see right here it's using the optimized DDS files for the textures. So that's just a very common process that you'll want to do when using the software. You'll usually import files as GLTF and then convert the textures to DDS and save it as a Leadwerks model, and that will give you the optimal loading time and reduced memory usage. Now this model is not super high poly. It's using 1700 polygons, which is fine. But if we want to, we can add some LODs to it. And an LOD, that stands for level of detail, and it's a reduced detail version of the model that is shown when the model is further away. So if we go up to Tools, Reduce Mesh, then we can use this slider to just gradually reduce the detail. It does a really nice job. So we're down to about 1130 polygons, so I'll just press Add LOD. That'll be my next version. And then reduce it a little bit more. Add LOD. It looks like that's about as low as it will go. And now you can see, here's our reduced version details. This one, okay, so the first LOD, that's the original mesh. That's 1700 polygons. This one is 1100 polygons, and the lowest is 482 polygons. And if you select the node here, the root, then right here, this LOD distance value, this will control the distance at which these different versions are shown. So let's just set these to be really low values so that we can see very clearly. Even then, it's pretty hard to tell the difference because you can see the change right there, but it's very, very close. Which is that's what we want. We don't want it to be very obvious when you change LODs. And then when you're done, you just save. And because this is a Leadwerks model file, it will save the LODs. Other model file formats do not support that feature. So you want to use Leadwerks model file formats for that. We can also add a collider to this model, and that way it will be interactive with 3D physics. Now by default, objects don't have collision unless they have a collider. So let's select the root node here, and then right here under physics, let's set a box collider. And that just does what it says. And now it will be, for the purposes of collision, this will be treated as a box. And we'll save that again. And then all of our changes are saved in the file. Now I want to show you how colliders work. By default, 3D models are not interactive with physics. You have to add a physics collider, which is a simple collision shape for physics to be active. And this is a really good model to test with. I'm going to select the root here, and then under physics, I can set the collider to box, and that just creates a box that matches the dimensions of the object. Well, I mean, that's not a very good match for this object. A cylinder isn't either. A sphere is not really appropriate either. Capsule doesn't really work. Convex hull is a bit better. That's not bad. But we have another tool that we can use, the special tool up here that's called convex decomposition. And what this does is it makes a series of convex hulls out of the shape. So let's see what it does by default. Oh, that's pretty good. It doesn't have to be a perfect match, but as long as it's pretty close, then it'll look good in game. So I'm going to save this, and I'm going to save as a Leadwerks model file format. This is a GLB file format, which is GLTF in binary form. But we want a Leadwerks model because that is that file format actually supports the physics colliders. Other file formats do not. So when we open this back up, we can see the physics collider is already applied to it. It's stored in the model file format. So this model is ready to use in game.